Okay, guys, I think we can start today's session. Okay, thanks for joining anyway. And in this session, we are going to start with the ROS 1 module. Okay, so I think some of you have already know about ROS, maybe some basic concept about ROS 1 specifically. And we will be seeing um, from the basics of ROS 1 to the advanced level in this module. And then our plan is to migrate into the newest version, which is ROS 2. Okay, because one of the things that we start learning ROS is that the latest version or latest version is ROS 2, but mostly like in this time, mostly like 2023, 24, 25. If you work with robots and ROS in this time, mostly you have to work with both the version. Okay, both the version, and you might encounter some porting of ROS 1 packages to ROS 2. Okay, so that's why we included both like ROS 1 and ROS 2 in this course. Okay, so if I'm directly teaching you ROS 2, then the problem is that the ROS 1 is not clear to you, and the porting of packages you can't able to do. Okay, so understanding both version will be essential in this time. Okay, uh, okay, so so this is a first session about ROS 1. Okay, and we are going to discuss the first chapter today, mostly the topics from the first chapter. I'm not sure I can able to finish it. Maybe this week we can spend some time on the first chapter. Okay, and in this chapter, the first chapter is kickstarting robot programming using ROS 1. What I'm trying to communicate is that what is robot programming, the importance of robot programming, and then where are we using ROS, the importance of it, those kind of stuff. Okay, so this is what I am trying to communicate. Okay, so this is a very basic session. You will get a lot of tutorials of ROS from web, but what I'm trying to discuss is that some of the things that I learned over these years. So I can simplify the concept like in a nutshell. Okay, I think there are some messages. Let me check. Yeah, so I think there is a message from Karan. So there are a lot of job for porting from ROS 1 to ROS 2. Yeah, so that's what I mentioned. Like currently, the ROS 1 ecosystem is actually porting or migrating to ROS 2. Okay, so it will be great if you can understand how the migration can be done, and that is what exactly we are discussing in the complete course. Okay, so you will know both the framework. Okay, so I just want to ask you a question. How many of you are already familiar with ROS 1? Can you just message? There is a message in the RDLP2 video voice channel. Maybe you can either message or you can just say how many of you already start working with ROS 1 or already have a good concept about ROS 1. Maybe you can just message in the chat. Maybe I can here. Okay, so how many of you already familiar with ROS? I just want to uh, get that first. Okay, and also if you are aware of the concept, I'm not sure how deep you understand the concept. That is also a thing, because you may be learning this concept from maybe from ROS Wiki or from maybe some from YouTube tutorials, or from maybe some recorded courses. Okay, so here this is a live course, so if you have any doubts you can ask. Okay, and then we can clarify these fundamentals. Okay, so this is very important because almost all the ROS 1 concepts are coming in ROS 2. Okay, okay, so I just want to okay, so I got an idea, like there are some people already message, some of you already have some concept about ROS 1. That is great. Okay, so let's start with the first concept. So what is robot programming? This is a very simple concept, so I'm not taking much effort into it. So what is robot programming? So anyone can say what is robot programming? Not like in a definition. From the robot programming, what do you understand? What is robot programming in simple words? Anyone can say? I mean, it's not like you have to say a correct definition or something like that. It's not. What did you understand? What do you understand when you heard robot programming? What is computer programming? Okay, if you're shy to answer my questions, no problem. Maybe I can explain, like a computer programming. Okay, so I think some of you are like unmuting. Maybe you can. Kalpesh, maybe you can talk. Your voice is not audible. Okay, okay, anyway, leave it. So computer programming, basically like programming the computer, programming using computers, right? And it's been, I mean, the computers are like there for I think 30 at least 30 years, right? It's there, the programming and the microcomputers and others are available. So we often call it as computer programming. And so what is the difference in robot programming? So in simple words, like what is robot programming? In simple words, it's programming robots. Yeah, Kalpesh mentioned execution of instruction. Yes, we are giving some instruction to the computer and it will execute, obviously. Yeah, yes, that is correct. And what is robot programming? Robot programming simply, I mean, it's almost the same. Like we are giving instruction to the robot and it is performing some jobs. Okay, basically in most of the robot, I will say in every robot, there is a computer inside it. Okay, computer, it may not be a full-fledged computer like desktop computer or a laptop or something like that. It can be a microcontroller. It can be a logic circuit. It can be a single board computer like Raspberry Pi. It can be Jetson Nano, anything. Like that's what we call the brain of the robot, right? So basically, like if you just check the block diagram of your robot, these are the important block diagram. Okay, you may have seen this, like sense, think, and act, right? So the important part of the robot, I will say, is the think module or think section, which is the brain of the robot, and the brain of the robot is a computer. Okay, so a robot programming simply means you are going to program a computer. So I will say it's a subset of the computer programming. Okay, because it's actually computer programming, but in robot programming, the computer is get connected to some sensors and actuators. Okay, so that is a basic building blocks of a robot. It is having sensors and actuators. It is connected to the computer or the think part of the robot, the brain of the robot. So robot programming simply is a computer programming. Okay, I will say it's a subset of computer programming, and it mainly involves processing the data from the sensor and then sending control signals to the actuator. So basically a robot will have a set of sensors. It will sense the environment, and based on the sensor data, we are processing it, and the brain of the robot is taking some decision and it is executing through the actuators. So that's what you can see here, okay, in the block diagram. So very simple example for a robot is an obstacle avoidance robot. Okay, so you can see a sense, think, act loop. Like the sensor of an obstacle avoidance robot is a sensor which can detect obstacle. It may be an ultrasonic sensor or an IR sensor or any sensor which can detect or sense an obstacle, then that sensor is connected to the brain of the robot. You can compare to human beings. I mean, we have 5 sensors and it is connected to the brain, and we are taking the decision, and then we are acting, or we are like taking decision, and we are making some, I mean, maybe some movements through our arms or legs or something, some other joints, right? So same thing is happening in robots, and the robot programming is happening on the brain. For human, we can take decision intelligently with the help of brain. I mean, we actually learned all the stuff from our childhood, and now we can take decision. But for robots, whenever it is creating, it should, I mean, start working. So fundamentally, we have to load some programs into the robot computer, then only it can sense and act. Okay, so that is fundamentally a robot and robot programming. Okay, if you have any question, you can either put it on the chat or you can just unmute and ask. Okay, so just want to show some sensors, actuators. Maybe you are familiar, like sensors, for example, camera is a sensor, wheel encoders is a sensor, ultrasonic is a sensor, and actuators are like servo, stepper, DC motors are all actuators. And the main part we are discussing is the computing unit, computer. So mainly we are using microcontroller platform like Arduino, then single board computers like Raspberry Pi, Jetson Nano, then mini computers, mini PC like Intel NUC. So these all are the computing platform. I mean, some of the computing platform. Okay, mostly we are using small computing unit, like small form factor computing unit, because of mostly the robot will be mobile, and the size also will be less. So in that case, if we are putting a big computing unit on the robot, then it will be difficult. So mostly we are preferring small form factor computers inside the robot. These are some of the sensors may be familiar with. You may be familiar with the ultrasonic, Velodyne, which is a LiDAR, 3D LiDAR, then depth sensors, all this stuff. Okay, and these are some actuators. Okay, so this is robot programming. Basically, we are taking the sensor data, processing it in the PC or the computer, and that's where we are programming it. That's where we are programming the robot, and based on your programming, it is taking the decision and then controlling the actuators. Okay, so now we can just start with ROS. So can anyone say what is the I mean, why we use ROS? What is the importance of ROS in robotics? Can anyone say or comment? I mean, if you are already familiar with ROS or if you are working with ROS, can anyone say why we are using ROS?
It's a framework.
Okay. Yes, it's a framework. And why we are using?
So,
Yeah.
so it basically provides, for example, if you want to build a humanoid robot, you
Okay.
have to program all the mechanics of it, like for example, how the joints works and everything. So, if you are making a robot for the first time, you are creating everything, and then if some other company wants to create the same thing, they have to reinvent the wheel. So the ROS provides a framework, so you don't have to create the mechanics for all the kinematics for the joints and all those things.
Okay. 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 Got it.
Provide abstraction.
Okay. Okay. Yeah, that is also correct. It's provide abstraction. Okay. Okay. Can anyone I mean explain in a simple words? I mean, uh, in the root level or in the fundamental level, what is ROS and why we are using it? I mean, what is the importance of it? I mean, can we use C++ or Python for programming robots? And why we require a framework? I mean, we are taking, I mean, an additional framework to program robots, right? Why we are doing it? So what is a fundamental thing that ROS provide to us? Can anyone say what is a fundamental thing. Yes, as Karan mentioned, it is giving some kinematics stuff, and we don't need to reinvent the wheel. That is correct. Then Kalpesh also mentioned it's providing an abstraction. That's all correct. But can you explain it in a very simple way? Like, what is a fundamental thing that ROS provide to us? Is it the abstraction? Is it the kinematics, or all the navigation, all those stuff? Or is there any other stuff? So Tanuj, because of there are a lot of packages in ROS, yes, I agree. There are a lot of packages based on ROS. But did you understand the fundamental, or what is a core part of ROS? Because that is the I will say that is the heart of ROS, and that actually that part actually gives all other features, meaning based on that feature only we can build these kinematics or like all other stuff. Okay, so Rohan is an easy communication between the hardware and software. Yeah, that is there. That is there. Communication between hardware using drivers is there, but still, if you understand, or if you learn the ROS framework clearly or thoroughly, you can answer this. Why? What is the core feature of ROS that we are using?
Like we are communicating with different languages with like one message type.
Yeah, the communication,
Yeah.
different languages. Yeah, so that is having some inputs from Tanuj. Yeah, the word actually communication actually comes with the different languages. Different languages mean different programming language. Yeah, I think you guys, I mean, talked about almost all the things about ROS only, but the fundamental thing that ROS provide to us is the inter-process communication. Inter-process communication. Specifically, I'm speaking inter-process communication, meaning if you want to communicate, or if one of your program want to communicate with another program running on your computer, that is actually possible through ROS. I can say it again. Like, imagine you are running two programs on your computer. Okay, two programs on your computer. For example, I have a like PDF reader. I have a browser with me. Okay, so these are two programs running on my computer. So if these programs can communicate with each other, that is actually called inter-process communication, meaning communication between process. Process means a running entity of a program called process. Running entity means if you run a program, if you compile a program and if you run it, it will become a process. Okay, so running entity of a program is called process, and ROS actually provides the fundamental thing, that is a communication between, or inter-process communication between multiple programs. Not only two programs, multiple programs. That actually create, I mean, a big scope. That actually opens a very big scope actually, because imagine you have a task to do. It can be done by different programs. Okay, like you have a task, a big task. Okay, instead of doing it in a single program, you can actually divide it and then split into multiple programs. Okay, so I can say the importance of splitting these tasks, in different program and completing the main code. Like if you have a big task, for example, if you want to navigate a robot from A to B, okay, so you may be thinking like, oh, moving from A to B, is it a simple task? Literally, it's not. It's not a simple task. Okay, so if you are planning to write everything in a single code, it actually like it will be very big, it's very difficult to maintain, and it will be buggy. I mean, it's not a recommended way of writing everything in a single program, okay, a single node. So that's why like we are going with like dividing individual subtask and executing by multiple programs. For example, like if you have a very big task, you can allocate individual subtask to each process, and each process will work on it and communicate as well. Communication means one process can send some data to another process or any process running. So let's say maybe I can explain using the PPT. So here there are three processes running, and program 1 can send some data to program 2, program 2 can send some data to program 1, and I mean in any combination, program 1 can maybe send to program 2, program 3, or program 3 can send to program 1. Any combination is possible. So just imagine the scope of this communication. Scope in the sense, what are the different things that we can achieve if the programs can able to communicate, right? Like it can be, I mean, it can be equated to like this. For example, there are 5 people, okay, there are 5 people, and one guy is doing all the job, or we are splitting the tasks to 5 guys, okay. So obviously if we are splitting the tasks to 5 guys and do, the throughput will be like, the efficiency will be increased. I mean, the entire task can be finished quickly, right? So if you want to split these tasks to 5 people, then there should be some communication should be established. Otherwise it will fail. If no one is communicating, then it will be fail. It will fail. So that is the difference. Like if you are doing a program in one program and in multiple program, it's actually very different. So in case of robotics, okay, in case of robots, we have, I mean, the robot have multiple sensors, okay, not a single sensor, multiple sensors. Robot is having multiple actuators. I'm talking about some advanced, not only advanced, like if you take most of the like mobile robots and all, it will have multiple sensors and multiple actuators, okay. So can you imagine like a single program, you are writing a single C++ or Python program to handle everything of the robot, like reading the sensor value, processing it, sending back to the actuators. Just imagine, it may be possible, but do you think that is the right way of doing? Will that be good? I mean, writing everything in a single program. I mean, we can able to do that, but in case of robot, that I will say that will not be a good method, okay, because if you are finding any bugs or something, it's very difficult to debug if the program size is very high, okay. But in case of a small program, if you just modularize your big programs into separate tasks, then it's very easy to debug. Debug means fixing the bugs and fixing the bugs, okay. And also another advantage is that if you can split the task into multiple programs, you can run some program in one computer, some program in another computer, and then these program can able to communicate, okay. So there are lot of scope actually if the programs are able to communicate and exchange data, okay. And this is what actually ROS provides to us. Okay, this is what I mentioned, inter-process communication, meaning you can create many programs or many as much as you want, many programs in your computer using ROS, and these programs can able to communicate with each other. Okay, if you want to send a data from a sensor node or a sensor node to program 3, for example, you can do that. So mainly like communication between different processes can be easily achieved using ROS APIs or ROS function. Okay, so ROS is actually a framework or a library. There are many terms for ROS. ROS, simply we can say it as a software framework, meaning it's a collection of functionalities, already implemented functionalities. Okay, so you don't need to reinvent the wheel. That's what Karan actually mentioned. There are a lot of functions actually implemented in ROS. Okay, the main functions are mainly for communication purpose. Okay, so in order to achieve a communication between multiple programs in your robot, you can simply use ROS APIs or ROS functions in your program. Okay, so you don't need to write code. You don't need to write code for communication. It's already available in ROS. Okay, then ROS will be taking care of sending data, receiving data, then all those stuff. Okay, so this is a fundamental part of ROS. Okay, and we are calling it as the ROS. We will call another name. It's a message passing interface, or like a message passing middleware. Okay, I'm not sure you have heard the word called middleware, which is actually like another layer of software which is acting between OS and the application. So if you can just search in Google, just middleware, so you can find some block diagram. So ROS is actually a middleware. Okay, it fundamentally is having a middleware. So you can see here is your application, and here is the API, and there is a middleware program between operating system and your application. So what middleware gives is that it is providing us with some APIs. APIs means application program interface, or simply functions to the application. Okay, so you are developing an application, and middleware will give you some functions. You can simply use this function in your program, and you can able to work on it. Okay, so what ROS gives to us is the functions to communicate between different programs. Okay, so I just want to make sure you understood this concept. I mean the inter-process communication. Okay, so inter-process communication can be done with multiple programs. It can be 10, 20, 100, any number. Okay, so just make sure that you got this concept called inter-process communication, which is what ROS provides to us. Okay, the ROS is actually a software framework comes middleware, which is giving us functions, okay, to your application or your program, and using that function, your application can able to communicate with each other. One application can send a string data to another application can send an integer data to this application. So any kind of data you can exchange. Okay, so let me know if you have any doubts or clarification on the inter-process communication, because this is what the important part. Okay, any confusion, guys? You can either comment or you can just unmute and ask. Any?
Sir, yeah. I have one question. Like in only C++ we are able to do inter-process communication, right? Not in Python.
No, not like that. I can clarify, Trushan. So in any programming language, we can able to do this inter-process communication. Inter-process communication, like you maybe heard about the server client architecture, right? Which is actually an inter-process communication, or socket programming, communicating through socket. So which is actually the core part of ROS. Okay, so inter-process communication can be done in multiple ways. So in Python, we can do inter-process communication through socket. You can easily do. In CPP, you can do. Okay, in multiple programs, inter-process communication is actually there. Okay, but the problem is, if you want to implement this inter-process communication from scratch, it will take time. Okay, and also it's not about the communication part. You have to send different kinds of data, right? You have to like send different kinds of data, and also you have to build maybe 10 or 20 or 30 nodes or application at the same time. Okay, so I mean, implementing from scratch or reinventing from the wheels will be very difficult. Okay, so that's why we are relying on ROS APIs for the communication. Okay, so if you are aware of OpenCV, open source computer vision library, which is actually for computer vision. Okay, so what OpenCV gives to us is the same thing, like it is giving some functions to us for doing computer vision application, for making computer vision application. Similar to that, what ROS gives to us is APIs for inter-process communication. So this is what happening on the fundamental level, and all other things that you are seeing is actually built on the top or from this. Actually, you can see the navigation, you can see manipulation, perception. All the things is based on this inter-process communication. Okay, so ROS is actually like compatible with multiple programming languages. Okay, so using ROS APIs, you can communicate from Python to C++. Like if you create an application in C++ and if you create an application in Python, both application can communicate with each other. Okay, because the APIs of Python and APIs of C++ will be different, but the communication part is the same for everything. Okay, so if you create an application in Android, for example, if you create some product prototype, then you may need a Android application to control the robot. Okay, so there is a API for Android, ROS Android. Okay, so you can create Android application using ROS APIs. So Android application can communicate to C++ or Python. Okay, so Tarun is having a question: is inter-process communication similar to function calling? Function calling, no. Maybe I can clarify. So ROS actually provides us with some functions. Okay, some functions. So you have to call this function on your program. Okay, then you can establish inter-process communication. Okay, when I show the demo, you will get to understand. Okay, so it is like you have to use the functions that is providing by ROS framework. Okay, in order to send and receive the data. Okay, then from the application point of view or from the user point of view, you don't need to do anything. You just need to call these functions. Then internally, this communication will be established. Okay, so this is what happening. If you have question, you can ask. I will show a demo, but even if you after watching the demo, if you have any doubt, you can ask. It is like a very basic example for ROS inter-process communication. Okay, so this is a C++ example that is already available in ROS. Okay, so don't worry about the commands. Okay, just check how the inter-process communication is working. Okay, no need to like check the commands. So I am actually starting a program, okay, which is actually running, and I'm starting another program. So this actually this is an example for inter-process communication. Basically, it shows these two programs are communicating with each other. Okay, so you can see one program, the first program, what it does is that it is actually sending a string data. Okay, so this is actually a string data called hello world 305 or something like that. It's keep on sending, and the intention of this program is that it will receive this data. Okay, so if I enter, you can see the data sending from this node, or this node means program or process. Okay, so you can see the data sending from this node is receiving here. Okay, meaning these two things are communicating actually. So when I stop this program, then this program also stop, because it's not receiving anything. So one is sending, one is receiving. Okay, so this is one of the very basic example that is actually present in ROS. Okay, just to demonstrate the inter-process communication, how it works. Okay, so just let me know if you have any question regarding the inter-process communication. Then I can say an example, this some more good example. So what actually ROS gives to us is what we are talking about. Okay, and the next thing that I'm going to explain is why we need inter-process communication in robots. I will clarify it. I just mentioned it, but I will clarify it. So both ROS 1 and ROS 2 is actually giving us APIs. Okay, both are giving APIs, but the difference is in the communication middleware. Okay, I mentioned that the middleware is actually a layer. It's actually a software. It is acting between the developer or the user and the operating system. Okay, so the user need not directly talk to the operating system. It will actually, the middleware actually making our life easy. It's providing some APIs in order to communicate with the different programs. Okay, so the middleware is actually the main difference between ROS 1 and ROS 2. ROS 1 middleware is actually not very secure, not very, real time, guaranteed. But ROS 2 is using a industrial standard middleware. Okay, so that is the main difference. I will say it's just a hurt replacement. Okay, from ROS 1 they replace the hurt and they put another hurt, okay, which is actually industrial compatible. Okay, the main thing is that ROS 1 and ROS 2s are entirely different framework. In the sense, it's not like an updation of ROS 1. ROS 2 is not an updation of ROS 1, but entirely newly written framework. Okay, because the company that is maintaining ROS, it's an organization called Open Robotics. They actually need to maintain ROS 1 and ROS 2 together. Okay, because a lot of people are still using ROS 1. Many companies are using ROS 1. So, they actually maintain both these framework well, so that anyone can use ROS 1 or ROS 2 based on their choice. Okay, so if you have any confusion regarding the inter-process communication, let me know. Otherwise, I will switch to a better example for inter-process communication. So here,
Actually,
yeah,
mixed up inter-process communication and intra-process communication.
Intra-process, I'm not very aware, but the inter-process communication is what the ROS gives to us.
Yeah. Actually, I just saw like there is a possibility in order to perform intra-process communication in a single node in C++,
Yeah.
but the same interface of API is not available for Python. So like that.
Okay. Yeah. So I mean, the inter process means, like, for example, if you run an application in C++ and if you run an application in Python, both are actually process. Okay, so the language is not actually a difference. If you run a program, it will become a process. Okay, so that's what I mean ROS gives to us. Inter process means even if you are working with any language like Android or Python, C++, Go or anything, it actually create a process, and these processes are getting communicated. Okay, so I think so that is the main thing that ROS offers to us. Okay, communication between process. So you can easily see the process running on your Ubuntu machine. If you have, from the system monitor, you can see the process running. You can see here the process. So these all are the process that is currently running. Okay, so the inter-process communication means like communication between any of these process. Okay, so internally in operating system level, there is communication between processes happening. There are many methods to do is like dbus. If you search about dbus, you can able to see it's a library or it's a framework for inter-process communication. Here you can see in computing, dbus is message-oriented middleware mechanism that allows communication between multiple processes running concurrently on the same machine. Okay, so this inter-process communication is actually required in operating system. In operating system, it's actually, I mean, there are multiple programs are running or processes running, and there should be some communication between. Okay, so in ROS, actually they give some easy APIs to us, and using that we can program. Okay, so actually ROS makes our life easy to create inter-process communication in your application. Okay, so so next question I just want to clarify. So some of the course members in my previous course actually asked, is ROS is an operating system? Like the term itself, robot operating system. So you might be thinking like, okay, it's an operating system like Windows or Ubuntu. So basically, the name is actually very catchy. Robot operating system is very catchy, but the thing is, it's not a real operating system. Again, it's a framework basically, but from the name, it's pretty confusing. Robot operating system. The thing is, it's actually having some features of the operating system. For example, the message passing interface, message passing, then file system. So there are some features that is common to an operating system and ROS. But basically, in order to install ROS or install this software framework, we need an operating system, if a complete operating system. For example, Ubuntu. Okay, Ubuntu or Windows, you can use Windows as well, but Ubuntu is one of the operating system which is completely supported ROS. Okay, so we are calling Ubuntu as a host operating system. So we need a host operating system to run ROS. Okay, so that's why I mentioned that like you need to install Ubuntu on your PC. It can be directly installed or you can use VirtualBox if you have enough computing resource. Okay, so ROS is not a real operating system. It's a software framework which can be installed in a host operating system. And one of the main feature that ROS gives to us is the inter-process communication. Okay, and maybe before explaining this example, I just want to ask, if you are already aware of ROS, do you think why we use ROS in a robot? So you may be using ROS in robots, maybe some of you. So why you are using ROS in robots? So like, is it like everyone is using it? So I am also using it. Is it like that, or do you have any specific reason to use ROS on your robot? Can anyone say? Do you have any specific reason to use ROS?
So like I use it for two reasons. One is I don't have to reinvent the wheel, and that reduces my time for development from idea to physical implementation of robot. And the second thing is it has a wide community. So even if there is a bug, the maturity level in order to reach for a particular package, a maturity level is the time is very less, so that you know that this system gonna work in worst case scenario.
Yeah. So when you work with robot, what are the things that ROS provide to you? I mean, you mentioned reinventing the wheel. You mentioned. So what are the features that ROS give to us? I mean, without.
One is interface with the hardware. So basically, all the drivers are already there by the community.
Okay.
So that people have already made agreed. The ROS provides an easy integration, so that you just need to download the package, configure some parameters, and you're good to go with that.
Okay, so you mainly use the drivers, which is giving the sensor data, right? Mostly, yeah, yeah.
Yes, and the move base, obviously, the navigation
Okay,
stack.
okay. So I think from Trushan point of view, like ROS is actually having some packages, which is the individual units in ROS. I will discuss that. So he's using because the vendors actually providing this driver to us. So in order to get the sensor data, you have to install ROS and install this package that given by the vendor. And then ROS is also giving some high level features like navigation, manipulation, perception. So we can simply reuse that functionality. Okay, so that is what Trushant, actually the reason why he is using it. Yeah, so these are some of the reason why people start using ROS, because imagine you are doing a project like navigating a robot from A to B, or like a pick and place of a robotic arm, or a four-legged robot, I mean quadruped robot. So in order to work these robots, you may have a hardware, you maybe bought it from some online vendors, and how to program it, that is the next question. How to move this robot, right? So if you create a robot, or if you buy a robot, you have to program it somehow, and you have to move the robot at least, right? So based on the inter-process communication in ROS, actually there are a lot of functionalities built on the top of this inter-process communication. One of the example is navigation. Okay, like using this inter-process communication, ROS is actually giving us some high level features like navigation, manipulation. Manipulation means pick and place robotic arm. Because of these features, people will get attracted to ROS, because in order to implement this navigation, you don't need to write a code. You don't need to write a code at least. You can simply download this package, configure for your robot, and then it's ready to go. So it's very interesting, right? You don't need to write a program actually. Everything is there. Everything is built already. Okay, so that's why most of the people are using ROS. Okay, and again, yeah, that is a big reason. Mostly, like if you check in internet, mostly the high level features, navigation, these things are people are looking for. Okay, so I just asked because I just want to explain the important blocks in ROS. Okay, I mentioned that the important part or heart of ROS is the inter-process communication, right? I already mentioned. And then based on this core feature or core part, there are some other things built up. I mean, we can call it as the inter-process communication as a foundation, on the top of the foundation, there are tools, capabilities, and ecosystem. I mean, ecosystem in general, the community, but tools and capabilities are made on the top of this inter-process communication. Okay, so basically, imagine there are 20 different programs running on your robot. 20 different programs running on your robot. Maybe 5 programs are reading the data from sensors, then sending that data to another program. Then some other programs are like processing this sensor data, and after processing it may be sending to another program. Okay, so these 20 programs are running on your computer inside the robot. So all these 20 programs are communicating with each other. Okay, so can you imagine what kind of structure it may be creating? Like 20 programs are there. 20 programs, you can consider each program as a oval shape. Okay, each program is an oval shape, and these 20 programs are communicating with each other. Okay, so if you indicate the communication from one node to another using a line or an arrow, what will be the shape, or what will be the final shape that you can imagine? If 20 programs are communicating with each other and one program is communicating to another using the communication is indicating using arrows. Okay, like this. You have already seen this, right? So if there is 20 programs, okay, I just mentioned 20 program for better imagination. So each programs you can indicate as an oval shape. Okay, and the communication is indicated through some arrows. So what will be the structure it is creating? Can you just visualize it in your mind? 20
If it's hierarchical, then it will be a tree of oval shaped blobs.
Okay, yeah, it's but it's not like one tree means there should be some root, right? Then from the root it will be like communicating. It's not like that. It is actually 20 applications are independent. Okay, 20 applications are independent, and these independent nodes are communicating to other nodes. Okay, so can you just think again? Like it's not like it.
Is it like a graph?
Yes, exactly. So it's actually kind of a graph. Okay, maybe I can just show you the picture. Just a second. Okay. Yeah, I think I have taken some. Just a second. I have included that thing, but let's see. Yeah, I think you got the point, right? The simply means like if maybe I can use a PPT for that. Just a sec. Let me create a slide. So this is our process, and then this is another. So all these things are independent. Okay, and these all are running on your operating system. Okay, process, and each process may be communicating to another program using this. Okay, this is what happening, right, in the inter-process communication. I mean, any programs can communicate to any node. Okay, so you can call a process as a node. Okay, that is also a terminology that we are using. So you can see each node, it is communicating in very different ways. Okay, there is no restriction. Any program can any process can, or any node can communicate to another node and send any kind of data. Okay, yeah, so Tarun also said, yeah, it's a bidirectional graph. Yes, so this will be the structure that create when multiple programs are communicating with each other. Okay, so in ROS we are calling it as computational graph. Computational graph. Okay, simply when you are creating ROS based application and when you communicate, when these programs are communicating, basically internally it's creating a computational graph. So why this computational graph instead of simple graph? Why? Because each process is doing some computation, right? Each process is doing something. It may be like reading from the sensor or processing the sensor data or doing something. So that's why we are calling it as ROS computational graph. Okay, so essentially using ROS APIs, we are creating ROS based application or ROS based node, which is altogether creates a computational graph. Okay, computational graph. This is what the important concept in ROS. Okay, basically it's create a computational graph. Okay, I think Karan actually sent some image. Let me check. Yeah, yeah. So there is a difference, Karan. Actually, yeah. Just a second. I can just show you this pic. Just a second. So this diagram, yeah, actually this diagram in ROS Wiki is contributed by one of my junior. This is basically for actually he put it for ROS 2, but maybe you can take this for ROS 1. In some sense it may work, but I will explain for, so don't confuse with it. I can just clarify how the communication with ROS 1 takes place. It's almost same. Okay, so I just want to mention that ROS, using ROS APIs, we are creating ROS application which altogether create a computational graph inside. Okay, why I am giving importance to computational graph is that in the upcoming topics you will see the importance. Okay, all the ROS concept is explained using this computational graph. Okay, and one more point is that I mentioned why we are using ROS in robots, right? So one of the reason is like I mean, it is having existing features, so you can simply download it and configure. Okay, so that is one thing. And there is no other robot framework available, okay, better than ROS, I will say, in all the aspect. ROS is actually a free and open source framework. You don't need to pay. Okay, ROS is a free and open source framework, and you don't need to pay, and it is having multiple packages that you want, and it is providing these inter-process communication capabilities, and then there are many other things that ROS provide, and also the community around it. Okay, so it's actually very big that you ever imagine. It's actually started in 2007, so you can see the legacy, like 2007, 2017, then it's 2022 now. Okay, so that much work actually happened in ROS. Okay, so this is a ROS equation. So basically ROS framework is having the heart, which is called the inter-process communication or plumbing, okay, which is another name that is giving to the inter-process communication. And using this inter-process communication or plumbing, we are basically creating what? The computational graph, right? Computational graph. So when this computational graph form internally, you have to debug it sometime. Okay, you have to debug it, because imagine one program is communicating to two nodes. Okay, sometime you have to check whether these nodes are communicating properly. Is it getting enough data? I mean, there are some debugging has to work, because it's not like writing a single program. It's like writing multiple program, and these multiple programs are communicating with each other. So this kind of program, I'm not sure you are familiar with. Mostly you may be writing a program in C++ or Python, a single program. But this kind of programming is like writing multiple program, kind of distributed computing. Meaning there are different process doing a big task in a distributed manner. Right? So that kind of programming may be confusing to you, okay, initially, but you will used to it, okay, once you get the correct concept. Okay, so I think you may get an idea, like even if you are familiar with ROS, you may be lacking some fundamentals. Okay, and the actual thing is in the fundamentals. If you are clear with the fundamentals, then only you can build things on the top of it. Okay, so this is very, very important. If you are going for a work or a masters or anything, these concepts should be pakka or very clear. Okay, and so I mentioned that the core part is plumbing, and in order to diagnose the computational graph, or in order to inspect or debug this computational graph in ROS, we have some tools. Okay, some tools. There are command line tools and there are GUI tools. Okay, so these tools are helping us to diagnose different nodes in the computation graph. Okay, so entirely like 20, imagine 20 programs are running all together. One node is sending to another node. So it's actually like a lot of things are going on in parallel. So these tools will help you to check what is actually going on now. Okay, or what is going wrong, those kind of stuff. So that is the second part of ROS. Okay, and the third part is what the popular part is. So this is actually the tip of iceberg. Okay, I will say this is actually the tip of iceberg, because this is what mainly people get attracted to it. The top level features, or we will call the capabilities. So the capabilities include navigation, manipulation, and perception. Okay, so maybe I can just show you some famous capabilities in ROS. ROS navigation, which is one of the famous ROS stack or package in ROS. Many people are using it, okay, in different form. So this ROS navigation capability, which is already built in ROS, which help us to navigate a robot or a wheeled robot from A to B autonomously. Okay, which is actually a very difficult task. Okay, so just imagine about self-driving cars. Self-driving cars are doing the same thing in a big scale. Okay, these ROS navigation stack is mainly for indoor robots. Indoor robots, it can be also work with outdoor, but mostly like small robots. Okay, not like self-driving car. Okay, self-driving cars are using a different stack. They may not be using ROS, they may be using their own framework for message passing. So that is, ROS navigation is one of the famous packages, okay, in ROS, which is built on what? Which is built on the inter-process communication fundamentally. Okay, and the second one is ROS Move It, which is helping us to create robot arm application. So mainly like pick and place, obstacle avoidance, then object detection and picking, bin picking. I mean, detecting objects from a bin and picking it. So all these kind of application, like robotic arm application can be done using ROS Move It, which is again a set of packages which is having a lot of implementation of inverse kinematics and then perception, all this stuff. So you don't need to build it from scratch. You can simply use it. Okay. So this is one example for the ROS navigation, which is mostly people get attracted to ROS. Okay. From my understanding, mostly people will like do this ROS navigation stack implementation, and they will think like they know all about ROS. Okay. Yeah, I mean, they will get something, but essentially you should understand the internal aspect. Okay. Then only you can make use of it, make use of this framework. Okay. That is same for all the frameworks available. Okay. So you can see here, the things that you are seeing is a tool. Okay. It's a visual tool available in ROS called ROS, which is for visualizing different data that is sending from each node. I mentioned that nodes are communicating and sending data, right? So using this ROS, you can see the different data that is sending through these nodes. Okay, so there are different kinds of data. There is laser scan, there is map, there is robot model, there is transformation. All this can be visualized in ROS. It's a very useful tool. Okay, there are command line tools as well. We will see that. Okay, so this is one simulation in ROS. We can just leave it. Just a sec. Let me reduce the sound. So this is an application of ROS based manipulation, meaning pick and place. Okay, I have actually taken this thing from some conferences. Yeah. So here you can see a real robot is working using ROS Move It. Okay, fundamentally on the right side you can see the ROS tool called ROS, which is visualizing all the data. And the robot, what robot does is that it is detecting a marker, Arco marker, and then it is taking that object and putting it on the platform. Okay, basic pick and place by detecting the markers. Okay, so all these things can be easily prototyped using ROS functionalities, mainly like Move It and Perception Stack. Okay, so in order to create this kind of application, the fun thing is that you don't need to write a single line of code. Okay, so just imagine how simple it is. Like if you want to prototype this kind of application using your own program, it will take a lot of time. So you don't need to like work hard to write implementing everything from scratch. You can take the existing thing, then you can refine it. Okay, so that is the third part of ROS, which is the capabilities, and this is simply a tip of iceberg. ROS is having lot of packages, tons of packages, not only navigation and manipulation, tons of packages. And yeah, the packages are actually the biggest attraction. Okay, because that will make our life easy. Okay, and the fourth one, which is again a useful, or like without it we may not start using ROS, that is the community. Very important one, because when you start learning anything like C++, Python, or OpenCV, ROS, anything, you will get issues. You will have like bugs, or like you will encounter many issues, right? So mostly you will go to Google and search. Imagine you are not getting proper answers from Google, or there is no one to reply for your queries. Then it's very difficult to survive, right? Mostly the software engineers are like living with Stack Overflow, because for me also, like the thing is that I'm not remembering each aspect of ROS. I know we can use this, we can use this, but if I'm trying to write my own ROS program by using ROS APIs, I can't write because I'm not memorizing all the API name or something. What I will do is I will simply search an example program and I will modify it. Okay, so those things are like we are getting that because of the ecosystem around this framework. Okay, so if you check it, if you simply search like ROS navigation stack error or something like that, you will get tons of answers. Okay, that is actually the community. A lot of people are like working on it. Okay, so that is very attraction point for ROS as well. So you will get instantaneous answers mostly. Okay, and finally I just want to show you the official website of ROS, and then we can conclude. So just have a look at the official website of ROS. So this is having the basic information, the equation that I have taught you. It's everything is there. Okay, I'm using the material from the ROS website only. Okay, so you can find the version that we are using for the course. Noetic Ninjamis is for ROS 1, okay, and ROS 2 Foxy. These two versions are we are using for our course. Okay, so there are instructions to install ROS and all, so that will be discussed tomorrow. Okay, so just ready with your Ubuntu installation. Okay, then we can check how to install ROS, and these things are very easy. Okay, and nothing to worry. Only thing is like understanding the fundamental concept of ROS, which is what the important stuff. Okay, so just go through this stuff. Okay, I mean, a lot of things are explained in the website itself. Okay, why we are using ROS, then community, yeah, ROS community. So just have a look onto it. Okay, so tomorrow we can start working on the installation and also all the things. So here this is the equation we have taken. Okay, plumbing, tools, capabilities, community. Okay, so you can just go through it. Okay, and tomorrow we can continue with the installation and all the stuff. Okay. Okay, so now it's time for Q&A. So let me know if you have any question regarding the fundamental things. I mean, we only discussed the essence of ROS. Okay, maybe tomorrow we will start discussing the ROS concepts. Okay, so let me know if you have any questions. If you have any question, you can either ask by unmuting, or you can just type.
Sir, I have
Sure.
one question. Like, I just want to know, is it worth it to go back to older ROS versions like Hydro and explore them for the sake of understanding how system has matured, or is it better to just stick on the newer ROS 2 version because that's going to
Yeah,
be the
that's
future?
a good question. The thing is that the advantage that you are getting if you go back, I mean, not much. Like, you don't need to go to Hydro or maybe from Kinetic Melodic, you will get an understanding, because from that you will get to know what are the packages. I think from Kinetic itself you will get a lot of packages are I mean, you can see a lot of packages in Kinetic 16.04. It was one of the popular version of ROS Kinetic with Ubuntu 16.04. So you will get to know the different packages, and mostly the Kinetic packages ported to Melodic. For Noetic, I think it's still not ported. I mean, most of the packages, important packages ported, but still there are a lot of packages not ported. So what you will get is that you will get an understanding if you just go from ROS, Electric, or Hydro. You will get an understanding how the packages evolve. But only try when you get time. But it may be worth. You will get how these packages transform. For example, the ROS navigation stack, okay, that we are using, it was another package actually. I think in Electric or before that, it was another package. The Move It was actually called ARM navigation package, okay, and then it's renamed to Move It. And then the navigation, I think it was a different, I forgot the name. So there are a lot of changes happen, but older version we are not going to use it, but you will get a timeline. You will get how these things transformed, how this software reached to this level. Okay. And also you can read about the ROS 2 design, okay, when you get time. So if you are already familiar with ROS 1 concept, then ROS 2 design also helps, because that will gives us like what is the differentiating factor in ROS 2. Okay, so yeah, so understanding this thing will help, but anyway we are not going to use versions lesser than ROS melodic, but you will get to know different packages. Okay, Trishant, yes. Okay.
Okay.
Any more question, guys?
I have a question about the hardware interface. So you said the drivers will be provided by for example, let's say if I buy a drone from the market, can I run the ROS directly on it, or do I need another interface in between?
So the thing is that some robots are already like having some packages, ROS packages compatible. So you can just simply download that packages and then you can work with it. For example, the JetBot, right? JetBot NVIDIA. So JetBot is actually, having ROS support, which is having Jetson Nano mounted. So these kind of kits are already loaded with ROS. Everything is in the Jetson Nano. But I will prefer you to buy a random kit that is not having a ROS support now, okay, and take it as a challenge and create an interface to ROS. Okay, so that will increase our learning. Okay, so that's what I am suggesting to course members, because if you are buying an existing kit like Turtlebot or something like that, you can work on the application side, because all the basic stuffs are implemented. So you can work on the navigation application or like those kind of application. But for this course, I will suggest you to either buy any kit and make it compatible with ROS or run with ROS, or create a kit from scratch, hardware from scratch. Okay, so that's why I included the 3D printing, modeling and all. Even if it is a small model or small design, not a problem, but you will get an understanding how you can prototype a robot from scratch. Okay, so that is what my intention is. So everything will be covered. But if you have any difficulty, or if you want to focus on the software side, then you can buy any kit and then make it compatible with ROS. Okay, Karan?
Yeah, got it. Yeah, so that was my question also, because like if you work in a company, they don't have like open source kits, they have proprietary hardwares. You have to write drivers from.
Yeah. So the thing is that for learning, I think we need basic kit like this. But for proprietary robots, for example, if you buy some proprietary robots, it is possible to like interface ROS if you know the APIs. In each robot, the interface actually like the challenging part. Okay, so you can buy a robot. Before buying, maybe you can like interact with me as well. If you are planning to buy some robots, you can interact. So I will also check whether we can make compatible with ROS. Okay, so then we can like make some interfaces that will increase our learning. So yeah, that's it. Yep. Any more question, Karan?
Thank you.
Okay.
No.
Yeah, so if you, I mean, you can buy any kit. I'm not suggesting specifically like a JetBot or something. JetBot is what I know, one kit, and you can buy any kit. Turtlebot is somewhat expensive. I have this, but yeah, it will work nicely, but it is somewhat costly. But you can simply build a simple differential drive robot like this. It's not a big thing. Differential drive robot, 2 wheels and like this. Okay, you can simply build it. Okay, try to build it, so you will learn the embedded system, sensor, I mean all those stuff. Okay, so that is what my intention is, to get a complete picture. So this is one project done by our course member France. Okay, so he actually created a big, I mean, complete documentation project, everything based on this robot. Okay, and it's also mentioned in my book as well. Okay, yes. Any more question, guys? Okay, so I think we can conclude for today. If you have any questions, you can ask me tomorrow, or you can put comments in Discord. Okay, then bye everyone, see you tomorrow. Okay, good night, bye.
Good night.